These notes will go over polarity, determining if something is polar or non-polar. First thing we're going to do is when a polar bond is formed, the shared pairs of electrons is pulled towards one of the two atoms. These electrons spend more time around that atom than they do the other atom. A partial charge occurs at the end of the bond. So we're going to look at these things as partial negatives. So I kind of make a fancy S and put a negative, or a partial positive, same kind of thing. Just kind of make it squiggly and something like that. Okay. The partial negative will go to the one that's more electronegative. So the negative goes to the one that's more electronegative, and the positive, the partial positive, will go to the one that's less electronegative. So we'll have to use either the general trends, or a table of electronegativity. So here is a table of electronegativities. All right, and we're going to look up the values. So there's carbon, 2.55, and then here is hydrogen, 2.02. This is going to be partially negative because it's a larger number. This is going to be partial positive. You're going to take your plus sign and you're going to draw what we call dipole arrows. So dipole arrows are simple arrows with one end. The tail is a positive and the head is an arrow. So we're going to start at the positive and draw the arrow towards the negative. So here again we have hydrogen, which is 2.20. Oxygen is 3.44. This is partially negative because it's the larger number. This is partially positive. So we're going to take the arrow and draw it, point it towards the more electronegative element. Try these two. Pause the video, try them on your own, and then check back in. So here we have 2.55 for carbon. Chlorine is 3.16. Partial negative, partial positive. Draw your arrow pointing to the one that is a larger electronegative value. You need to have one end with a positive, the other end should be an arrowhead. Here we have hydrogen, which is 2.20, and sulfur, which is here 2.58. Partial negative, partial positive. You're going to take this and draw it this way. Now I realize this arrow and this arrow are all pointing the same direction. That's just because of the way these examples came off. If you notice, on this side we had one arrow pointing the other direction. So it's always pointing towards the larger number. Okay, so this is now a molecular formula. So we're going to have to go through and draw the Lewis structure or the geometric structure. Most of these, the geometric drawing is going to be more helpful to see polarity. So this is going to be sulfur, which is in family 6, and 2 chlorines, each in family 7, so we need 20. So we're going to do sulfur like this, and we know that we need octet, so we're going to go through giving everybody octet, and then we have 20, so we know this is bent. So you can draw it bent. And now we're going to establish the values. So first thing we're going to do is look up sulfur. Sulfur is, I wanted to change color, so give me just a second, 2.58. And each chlorine is 3.16. So now you're going to look at each set of bonds and draw your dipole arrows like we did before. You do not need to do this part where we're going to put the partial negative and partial positive. And this is going to be partial negative in that one. So it's going to go this direction there, and then this one's going to go this direction. So overall, the dipole would be that direction. If this is pulling this way, think of this kind of suspended on a string, right, or a bungee cord. If I pull it this way, and with the same amount of force I pull it this way, generally speaking, it's going to come straight down that way. So our overall dipole is this green arrow. Okay, looking on to the next one, we have hydrogen, and which is 2, and sulfur, which is 6, so we need 8. So we have this Lewis structure. So I'm going to use the space over here. I'm going to bend it. Ooh, that wasn't very good. Let's make that look a little bit nicer. That almost looked like an A. Actually, let's just start that over. So we have sulfur, hydrogen, hydrogen, lone pairs, lone pairs. Remember that sulfur needs 2, 4, 6, 8, hydrogen does not. Now we're going to look up their values. So we're going to do sulfur, which is 2.58, and each hydrogen is 2.20, 2.20. So for every attachment pieces, you're going to explore the dipole arrow. Okay, so this is going to be this direction, because this one would be partial positive, this one would be partial negative, this is partial positive, and it's going to be in that direction. So your overall dipole is going to be that direction. Okay? If this is pulling this way, right, and this is pulling that way, overall it's going to go straight up. So it does have. So that being said, if there is a pole, okay, that's what we're going to call it. If the overall direction has a pole, then it's polar. So this is polar, and this is also polar, because it has a general pole with quotation marks, meaning a region in space where the electrons reside more often with one atom versus the other. So both of these are polar because they have an overall dipole moment.